Hello, Dr. Baumstark back here. I'm going to talk about the domain name system in this video. Just some examples of how it works. So let's start. Adding a new page. Let's take a host name. Like www.yahoo.com. One of the things that the domain name system allows us to do, actually the thing it allows us to do, is to translate this human readable host name something that's easy to remember, and in this case www.yahoo.com, into something that's computer readable, or more appropriately, something that is more understandable by a computer. In this case, it's the IP address. And just for kicks, let's look up what that IP address will be. We use 69.147.125.65. So, very easy to remember for us as humans, www.yahoo.com, but in the end this is meaningless to a computer. And to actually get to that website, to actually have the computer communicate with that host name in any way, we have to translate it into an IP address. And the domain name system is what performs that for us. So what we're going to do is show a little bit about how this works. Now, first of all, let's look at this host name and kind of pick it apart. There are several components to it, the first of which is the root domain, which actually is empty, although it's easy for our purposes to designate it as a single dot. And I'm actually going to modify the address with a dot on the end, like so. The dot is just a delimiter. It breaks up the various pieces of our host name, and technically there is an empty string here on the end that represents the root domain. But generally we don't even represent the dot. It's just for our illustration here, it's convenient to do so, to help us remember that there is an implied root domain on the end of this host name. The next piece is the top level domain. For our address here, this is .com. There are others. You've seen .org, .net, .edu. There's even a .mil for military use, .gov for government use, as well as there's several others. But all of these are what we call the top level domains. In our particular case, this is .com. Then there is the domain itself, which in our case is yahoo.com. So this domain is actually owned by and is managed by Yahoo itself. And most domains, it's a private thing that is owned by a particular company or nonprofit or any other kind of organization, and they manage all of the host names within that domain themselves, or in some cases they designate somebody else to do so on their behalf. But they ultimately have control over the host names that are available under that domain name. And finally, in this case, we have the computer part. And in this case, the computer is www.yahoo.com. Now, sometimes these are called services because it may not represent a specific computer, but in the end, it is the actual device that we are trying to get to. So let's start. Next, here's your PC. Here is a website they want to go to. And let's look at the interaction. Now, PC wants to communicate with www.yahoo.com, but it does not have an IP address for it yet. So before your browser or whatever can actually initiate an HTTP session with www.yahoo.com, the first thing it must do is query a DNS server. So what it's going to do, it's going to ask the server, what is the IP address of www.yahoo.com? And that DNS server is going to give us a response back. In this case, it's going to be that IP address. I'm going to shrink down a little bit. And there we go. So now that we know the IP address, we can continue on, make our HTTP request to that website, and get our HTTP response. Assuming we're just trying to load a web page, which is obviously what we do. We do a lot of that. Anytime your PC tries to load a website, do an FTP session, do a chat session with a host name that it does not know, it has to contact an external DNS server and ask that server what is the IP address for that host name. That happens before any connections are established with the site we want to go to. It's a very fundamental piece of internet architecture. Without it, we would have to remember lots and lots of numeric IP addresses, and which would just make things a whole lot less user-friendly. Now, this is what you're seeing in front of you is a fairly simplistic model. It assumes that this DNS server can resolve all host names on the internet. In practice, that is not true. So let's expand on our model a little bit. So let's consider a setup like you may have at home. You have a PC. And that PC has programmed into it the IP address of a DNS server, one probably given to you by your ISP, say Comcast. So every time your PC wants to know what the IP address is for a host name, it's going to ask, in this case, Comcast's DNS server. Which again was when you set your computer up to work with Comcast network, they in some form or fashion actually gave you the hard IP address of their DNS server. Your PC thinks it's always getting DNS information from that server, but the fact of the matter is that it does not know the address of it does not know the IP address of every host name on the internet. The scale of such a database is just too big. No one computer could handle all of that. Instead, we break things up, and this is related to all the pieces of the address that we discussed a couple slides back. Let's follow the actual process now. Go red. So step one, you want to resolve www.yahoo.com. So the first step is you ask the DNS that you know about. It's the one that's programmed, the one that is whose IP address is stored on your computer. You can talk to them directly. You don't have to resolve their host name because you've already got their IP address. So you ask them, what is the IP for www.yahoo.com? As I said before, they probably don't know. What they do know is who to ask to get that information from. And what this actually does is it kicks off a fairly long chain of events, or well, several steps of events, that start with querying the root domain. And the root domain is handled by a set of servers called the top level domain DNS servers. So that was step two. Comcast knows to start the query process by asking those servers, what is www.yahoo.com? Again, for reasons of efficiency and not trying to do everything in one place, which would bog things down, it turns out the DNS server, those top-level domain DNS servers, don't know. What they do have is they have IP addresses of DNS servers that can handle addresses in the .com top-level domain. And we call these the global top-level domain servers. And these are GTLDs for short. There are global top-level domain servers for .coms, for .orgs, .govs, .edus. There's some overlap between those, but there are servers that can handle each and all of those top-level domains. So that becomes step 3 of the process. And so once again, our computer here has contacted the DNS that it knows about, which of course actually did not know the IP address we were looking for. So it kicks off this chain of events that starts by querying the top-level domain DNS servers. Those only know about how to find servers that can deal with .com, .org, .gov, whatever type addresses. And so it passes off your request to the global top-level domain servers, which can continue this chain of events. Now, we've resolved up to the top-level domain part of our address. The next piece is that we need to resolve the actual domain itself. This is where the global top-level domain servers come in. They know about DNS servers for individual businesses, organizations, nonprofits, whatever. So each one of those organizations is going to register its domain with the global top-level domain servers. And usually that's done through a third party like GoDaddy or somebody who can do domain name registration for you. So we'll add this into our diagram. The global top-level domain servers are going to point us at a DNS that is authoritative for yahoo.com addresses, or for yahoo.com host names. Typically, or at least in the simplest case, this is a domain name system server that yahoo.com owns and operates on its own. And it's not uncommon for an organization to, buy DNS hosting from somebody else. But for simplicity, it's let's just say that yahoo.com actually maintains the machine that this server is running on, which means they can add computers to it, new host names within that domain as much as they like, because they have control of everything inside that domain. So that's the next step of the chain of events. Now, at this point, we have gotten to a server that knows how to resolve yahoo.com host names. Well, that means that this server knows how to resolve that host name, www.yahoo.com. They maintain the database of all those computer names. It's going to have the IP address stored in that, and so this it's going to send all that information back to here, back to Comcast DNS. And I'll explain why that happens in a moment. So once Comcast DNS receives that IP address, it forwards it back to the PC that originally requested it, and we're done. Now the PC can use that IP address for whatever communication with this host name that it desires. Now, a couple points here. The first thing, from the PC standpoint, all communication was with this DNS. It doesn't see the other steps in the process. It doesn't need to. All it cares about is that it asked a DNS server for an IP address, and it got that IP address back. So keep that in mind. It's kind of ignorant of the rest of these steps. Although if you want to, using a tool like Dig, you can trace through that and see all the steps that were taken. The other thing is this is why this step 5. Why did we send the IP address for this host name back to Comcast DNS and not directly to the PC? The answer is caching. So let's do this for just a second. Say this is Comcast's DNS. Now, Comcast has millions of users. Well, in Atlanta alone, I'm sure they have a couple million. So you've got thousands, maybe millions of users, all talking to Comcast DNS. Say person A went to www.yahoo.com. And we went through this whole process here to resolve that address. That takes some time. Now, obviously, yahoo.com is an address we go to a lot, probably only eclipsed by Google in many cases. A forced Comcast DNS to go through the resolution process. So what if B also wanted to go to www.yahoo.com? Does it make sense to go through this entire process again? Or does it make sense for Comcast to cache that IP address for some amount of time? So if Comcast can remember the results of this, what we call a recursive lookup of a host name, if Comcast can remember that, then all their other customers get the benefit of that lookup. So we do it once, we go through that fairly expensive process one time, and then all million of Comcast customers can benefit from that. So that when other customers want to do it, all they have to do is ask Comcast DNS, and it can respond with what it has cached or remembered. It's just an efficiency tactic, and eventually the cache will time itself out and force a relookup when somebody asks. But it's still, if you hold on to that IP address for some time and cache it, then you're going to get a performance benefit across the entire network. So okay, that is a DNS example in a nutshell. If you have any questions about this, please let me know, and I will do my best to clear them up. Thank you.